Welcome to Lab 5. In Lab 5, we're just going to be continuing our use of descriptive statistics using JASP. But this time we're going to focus in a little bit on standard deviation and think about that descriptive statistic in particular. So before we get started on our lab, make sure that you've downloaded the data set, which I'm going to do right now. That's the first thing I'm going to do. I'm going to save it to my Documents folder. And in doing so, I can then upload it into JASP. All right, I'm going to minimize that. And then if you don't have the lab instructions, you might want to have them to follow along. So I'm going to open them up. All right. So what we have in this lab is a study of a group of Psychology 101 students. And the relationship between stress was examined between stress and academic performance in students and stress and their engagement with the campus community. So in this study, students completed a number of assessments and that measured stress and engagement with campus resources, clubs, etc. And then there was also a final quiz score and overall points accumulated during the semester were included in the data set as well. So these are measures of academic performance. And then we always collect some additional demographic conditions. Now we do something very different with this data set, and that is we take the continuous variable or the scale variable of the number of reported credits, and we're going to we turned it into, actually in the Excel data set, into a nominal variable of part-time students and full-time students. So based on those number of credits, they were put into one of two groups, in other words. This is an example of sometimes where we can take a scale variable, a continuous variable, an equal interval variable, these are all synonymous, and turn it into a nominal variable for other purposes. And then we can do the same for the stress scores. So we can take this ratio variable of stress scores or continuous variable, scale variable, and say that stress scores between 0 and a certain number are considered low stress scores, and that certain number in the top score are considered high stress scores. So we can take stress scores and divide students into two different groups, low stress and high stress. And that was done in your Excel sheet. We're going to look at the data in just a minute. So we have our regular directions here. So what I'm going to do is I'm going to skip down and just show you that you do have a table that shows how we're going to label some of the variables. So gender, 1 was male, 2 was female. Enrollment, 1 was part-time, 2 was full-time. Stress level, 1 was low stress and 2 was high stress. All right, so we're going to go to our analysis steps. But before I do that, I'm going to go ahead and open up JASP and upload the data. So I'm going to go to my computer and I'm going to go to my documents, and there's the Lab 5 data. All right. So the very first thing that we have to do before we even get started is we have to clean the data. And so this is not even in your directions. This is just something that at this point you need to know how to do, and that is clean the data. Make sure that the variables match the type of variables that JASP thinks they are. So we have age here, and that is a continuous scale variable. So we have a ruler, that's good. And we have gender, which is nominal, yes, and we're going to fill in the value labels in just a moment. We have the number of credits, and that is a scale variable, that is true. But for quiz, that is actually a scale variable. That's their quiz score. So we want to make sure that that is shown as a scale. The number of points in the class is a scale variable. Their stress score is a scale variable. Their engagement score is also a scale variable. And enrollment and stress level are appropriately classified as nominal variables. So take a look at these variables right now and make sure that your output is going to match this. We have 3 nominal variables and the rest are scale variables. All right, it's time to put in our labels. So I'm going to come over here to gender and I'm going to click on the word gender and I'm going to type in male and female. And Remember that I have to hit enter after the last one to make sure that it registers, and then I can close it this way. The next one was enrollment, so I click on the word enrollment, and for one I'm going to put part-time. I'm going to make it one word, and for two it's going to be full-time. And I'm going to hit enter again, and I'm going to close it out. And for stress level, I'm going to, I hit the wrong thing. I need to hit the word stress. And then I'm going to say low stress, L-O-W, and I'm going to make it one word. And then high stress. And I'm hit enter. All right. So now we've done the first step, which was to enter the labels. And actually, I just looked at your directions, and it does say clean the data. So it is in your directions, but there you go. So now it's time for the analysis. So let's look at the first analysis. It says to go to the Descriptives menu and click on Descriptive Statistics. And we are going to check the box for frequency table. That is what our directions tell us to do. And then we're going to move all the nominal variables into the variables box. And then, if you will recall, we need to get rid of the mean, the standard deviation, all that good stuff, because we actually cannot calculate those on a nominal variable. So it just makes for too much noise on the paper. So that is the first one that we needed to do. Let's take a look and see what we have. So that gave us tables, frequency tables for our gender, for our enrollment, and our stress level, our three nominal variables. So it looks like we had 50 males and 58 females, and we get percents. This is basically the information that a frequency table will give us. It's just how many and what percent. We don't know mean, median, mode. We can't do that on these things. They're nominal variables. All right, if you will recall, when you want to do your next analysis, you have to come up to descriptives again. You don't want to start moving anything around here because it will mess up the tables on the right. So I'm going to go to my descriptives menu, and it says to select all the scale variables. Okay, I can do that. Anything with a ruler, in other words. These are either equal interval or ratio data. My guess is that they're all ratio. All right, and that is all we need to do for that part 2. Look and see what we have. Now, since these are ratio data or equal interval, continuous scale, I can do a mean, I can do a standard deviation. So let's take a look and see what the standard deviation of age tells us. So the mean age in this group of students was 21.90. So let's just call it 22, shall we? And the standard deviation is 5.009. That means, let's just call it 5. So this means that, on average, the ages vary by about 5 years from the mean. So the mean is 22, and on average, the ages vary from that mean by 5 years. So I'm going to ask you a question. We know that one standard deviation is 5. What if we add one standard deviation to the mean of 22? Well, the age at that one standard deviation would be 27. What if we find the average, or the age, I'm sorry, at -1 standard deviation? Well, that's 22 minus 5, and that would be 17. So what we do know is that between the age of 17 and the age of 27, about 68% of the scores are there. Why is that? Well, that's because between -1 standard deviation and +1 standard deviation are 68% of the scores. Let's try this another way. We have our mean of 22. Our standard deviation is 5. What scores represent the boundaries for 95% of the distribution? Well, I know that 95% of the distribution is between -2 standard deviations and +2 standard deviations, or z-scores of -2 and +2. And so that just means that instead of just adding a standard deviation of 5 to get to 1 standard deviation, I'm going to add 10. So the score at positive 2 standard deviations is 32. The mean was 22. Plus 1 standard deviation gives us 27. Plus another standard deviation gives us 32. We can also go backwards. So we added 10 basically to the mean here. So to find the score, the age at negative 2 standard deviations, or 2 standard deviations below the mean, we just subtract 10 from the mean. So 12 is at the age of 12. Now, obviously there are people that were 12 years old in this group, but this is mathematically how it would work. So the z-score of negative 2 is equal to an age of 12. So we can say that 95% of the ages in this class ranged between 12 and 32. So you're going to do some practice with this later, so think about that. All right, I'm going to go back. I've been talking a lot, and the next part we're going to do is we're going to go to Descriptive Statistics again, start a new one. This is to move gender to the split box. Okay, that means I'm going to be splitting out whatever data I put up here by gender. And then it says to move quiz, engagement, points, and stress to the variables box. Okay, I can do that. Quiz, engagement, whoops, oh, I just moved it over. I don't know how I did that. Quiz, engagement, points, and stress. Doesn't really matter what order you put them in. Okay. So that gives us all the descriptive statistics by gender. So now I have engagement scores. I know the mean of the males, I know the mean of the females, and the standard deviation of the males, and the standard deviation of the females. Same for quiz scores, same for points, same for stress. So my question to you is this: who had the higher points on average in the course, males or females? Well, males had 552 and females had 485, so males had higher on average in this case. All right, who had higher engagement? Looks like males had higher engagement scores as well. Okay, so I'm going to close this out. That is the first one we need to do. The second one says to do your descriptive statistics again, but this time it says to move enrollment to the split box. So this is going to be the part-time versus full-time student status. I'm going to move this to the split box. And then it says to move quiz, engagement, points, and stress again. Quiz. I'll just move that. Engagement, points, and stress. Okay, now I have stress level here and stress. Why did I not put stress level over here? Well, first of all, it didn't ask for stress level, it asked for stress. And second of all, the variables box here, only when we are splitting by a nominal variable, we can only look at the scale variables. So that is why. All right. So what do we have here? I'm just going to go back down here. So now I can look at the difference between part-time students and full-time students in terms of their quiz scores. So who did better on the quiz, part-time students or full-time students? Well, it looks like part-time students did. The mean of 15 is bigger than this mean of 14. Interesting. What is it about part-time students that made them do better on the quiz? I'm always curious about these things. All right, that is the second one in part 3. Now the third one says to move stress level to the split box. Okay, here we go. And again, why am I moving stress level as opposed to stress? Well, first of all, it asked for stress level. And second of all, in the split box, we can only put nominal variables, right? And then it says to move quiz, engagement, and points to the variables box. So quiz, engagement, and points. Didn't ask for stress. Why is that? Well, because we've got stress here. So there you go. So now I know, based on a person's stress level, how engaged they are, for example. So who is more engaged in like campus activities and things like that? Looks like the low stress people had higher mean engagement scores, so they are more engaged. Kind of makes sense. When you're stressed out, maybe you're less likely to engage. Who has the highest quiz score here? Low stress or high stress? Well, interestingly enough, it's the low stress people again. So maybe being stressed out impacts your ability to concentrate. All right, so that is, I think, everything on the directions. I hope I've gotten everything. So what do we do now? Well, we have to save everything. I'm going to show you 2 different ways to do it again. You know the drill though. So I'm going to come up here to results. I'm going to hit copy, and then I'm going to copy it, and then I'm going to paste it in a Word document and save it. Or I'm going to come to the 3 little lines right here. I'm going to export my results, and I'll do that to my documents folder, and that saves it as a HTML file that you can submit. Works like a charm. And that is our lab for today. Now, the lab worksheets are going to ask you to really dig into these data. You have 2 tries on the lab worksheet, so make sure that if you miss something the first time around, just go back and really look and study and think about it for the second time around. Okay, have fun with this lab. I hope you enjoy it.